Okay, this question, this is the final question in a past paper. And if you look down the side, you'll see we've got 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13. 13 marks is well over 20%. We're looking at about something like 22% here. So just imagine that, the very last question you'll be doing at Penthorpe, and they've sneakily put 20 odd% on it. Okay, so be very careful of things like that. Alright, now then, first one. So this is James hammers some fence posts into the ground in his garden. One post has a tip which has an area of 2 centimeters squared. When the hammer hits the post, it causes a force of 500 newtons to act on it. Give the equation that relates pressure, force and area, so PFA, so we're thinking French people annoy. And then we look ahead and we see that they're going to ask us about the pressure. So we find this in terms of pressure. Okay, so pressure equals. Then we go down here and we write in pressure equals, and then we know the force, which is 500. We know the area, because that's given to us as 2. And the units, obviously, we need to do newtons per centimeter squared. So we're doing 500 divided by 2. So we do the same with the units. Newtons divided by centimeter squared. Newtons per centimeter squared. Okay, next one. For 2 marks. Some of the posts have sharper points than others. Explain why James finds it easier to hit the sharper post into the ground. So generally people put things like it goes into the ground easier. We want to try and link that to this earlier part of the question, because when we sharpen them, we reduce the area. Okay. If you reduce the area, then you generate more pressure. Okay. So that is why they go into the ground earlier. Go into the ground easier. I apologize. Okay. On to the next one. James uncovers a large rock in his garden. He cannot easily move it, so he uses a fence post as a lever to help him. He uses a round stone as a pivot. So we've got a stone here, we've got the fence post here. Okay, so we're thinking pivots, we're thinking moment. The horizontal distance from James to the stone pivot is 2 meters, given here. He pushes down with a force of 40 newtons and the rock just starts to lift. So find the moment that James is producing. Okay. So we're looking at giving the unit as well. So moment, force and distance. So mum fancies dad. So moment equals force times distance. So we'd write that down. Bear in mind this is for 3 marks, so I'd write the full thing down. Moment equals force times distance. I will put in the 2 bits of information I've got. The force is 40. The distance is 2. So 40 times 2 would be 80. And the units, because we are timesing these 2 numbers together, we would times these units together. So it would be Newton meters for 3 marks. So the next one. The horizontal distance from the rock to the stone pivot is 0.5 meters. Ignoring the weight of the post, calculate the weight of the rock. So weight and force are the same thing. Okay, so here it's telling us that this distance here is 0.5 meters. Okay, it's also told us that this just moves. So the moment on this side must equal the moment on this side. So we can look at the clockwise and the anti-clockwise way of movement. So we know the moment on this side, and we can calculate the moment on this side because we've got the moment and we've also got the distance. Okay, that's for 2 marks. In reality, the post does have weight. State whether this means that the weight of the rock is less than, more than, or the same as the answer. So what it's saying is, if you look back to your diagram, this post, we've ignored the weight of the post so far, but obviously the length of that means there's quite a bit of heavy wood on this side. Okay, so if you take that into account, then this rock must be heavier because we've actually got more than 40 newtons on this side. We've got a bit more because of the weight of the post. Even if you had no idea, it's given you the 3 options to try. So is it less than, more than, or the same? Please don't leave any questions like that blank. Put something down. And on to the next one. State two things which James could do to increase the moment which he's producing. Okay, now we're looking for sensible suggestions even on how he could increase that moment. So what he could do is he could put more force on this side. So he could get a friend and they might be able to put 80 newtons force on this side. You could lengthen this distance, so you could get a longer pole and that would increase the moment as well. You could also move the stone pivot. Now, you can't just write an answer of move stone pivot, you have to say which way you're going to move it. You want to move it so that it lengthens this distance, because that would increase the moment on this side. So you'd move the stone pivot towards the big rock. Okay, so move it to the left or something like that. Don't just say move the stone pivot. Okay, so that covers everything on there. Like I said, sensible suggestions. Don't be putting things like blow it up with dynamite and stuff like that. Okay, thank you.